Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the inbuilt timers and counters in 8051. The slides are prepared by referring the textbook, the microcontroller, 8051 microcontroller, author Kenneth Ayala, publication Singh's Learning. A timer is a clock that controls the sequence of an event while counting in fixed interval of time. It is used for producing precise time delay. Secondly, it can be used to repeat or initiate an action after at a known period of time by providing a delay. Most microcontrollers have built-in timers that not only generate time delays but also used as counters to count an action or an event. The value of a counter increases by 1 every time it corresponding to an action or an event occurs. Timers in a microcontroller are inbuilt chips that are controlled by specific registers, that is SFR, special function registers assigned for timer operation. These SFRs are used to configure the timers or counters in different modes of operation. In 8051 microcontroller, it consists of two timers which we can use as timers or counters depending upon the clock frequency. The timer or counter can be used for time delay generation or counting external events. For 8051 microcontroller, the crystal oscillator which is connected for XTAL1 and XTAL2 pin will generate a clock frequency with frequency of 11.0592 MHz. Whatever the clock frequency which is generated, it will be divided by 2 for 1 mission cycle. And these pulses which are divided by 12 will be given for the timers, either for timer application or counting application. Every timer needs a clock to work, and 8051 provides it from a crystal oscillator which is external to the main clock source for timer. The internal circuitry in the 8051 microcontroller provides a clock source to the timers which is 1/12 of the frequency of crystal oscillator which is attached to the microcontroller, also called mission cycle frequency. In 8051 microcontroller, it is consist of various registers. For timers, there are two timers, that is timer 0 and timer 1. These two timers are 16-bit size. The size of these registers T0, T1 are of 16-bit size. Since 8051 microcontroller has an 8-bit architecture, each of these is accessed by two separate 8-bit registers as shown in the figure. For timer 0, that is T0, it is consist of D0 to D15 which is 16-bit size. These values we are going to be moved into two registers, namely TL0 and TH0. TL0 consists of the lower byte, that is from D0 to D7 of T0, and from D8 to D15 are moved into the TH register. Similarly, for timer 1, that is T1 register, which is 16-bit size, that is bits from D0 to D15, are provided in two registers, that is TL1 and TH1. The TL1, which is timer 1 low register, which is consist of the bits from D0 to D7, whereas TH1 will contain the bits from D8 to D15. As 8051 microcontroller is a 8-bit microcontroller, so the data whichever we are going to be transferred through the data bus is only 8-bit size. 8051 has a one more register for mode configuration and controlling the timers, timer mode register and timer control register for selecting a mode of operation and controlling purpose. The next register we will see, that is T mode register. The T mode TMOD is an 8-bit register used to set timer for modes, but for both timer 0 and timer 1. It has lower 4 bits used for timer 0, upper 4 bits are used for timer 1. These timers either we can use as timers as well as counter. By programming T mode registers, we can configure the timers to be functionate as timers or to functionate as counters. 8051 has a time mode register and T-count registers. These two registers we have to configure before using the timer applications. The various bit of T mode registers: gate, which is a enable timer or counter when the INT0 and INT1, which are external interrupt pins, is high, and the timer run for timer 0 TR0 and timer run 1 as TR1 is set. Then only the gate will be enabled. The next bit is C by T bar. This bit is to configure to use 8051 timers as counters or timers. C by T bar, if it is equivalent to 1, then these timers will functionate as counter. If C by T bar is equivalent to 0, then these are configured as timers. There are a separate line for C by T bar for timer 1 and C by T bar for timer 0. By programming this bit C by T bar bit either for timer 0 or timer 1, we can use the timers as timers or counters. The M1, M0 bits are used for configuring the timers in various modes. For timer 1, a separate M1, M0. For timer 0, we have M1 and M0. Total, we have 4 modes of operation. The various modes of operation for the timers are, if we configure the M1, M0 bits as 00, it is mode 0, which is 13-bit timer mode. In this 13-bit timer mode, 8 bits are assigned for THX and 5 bits are assigned for TLX. The upper 3 bits of TLX are don't cares, that we are not going to be configured. Here X stands for either it is for 0 or 1. If you are configuring timer 0, these 8 bits we have to load into TH0, 5 bits we have to load into TL0. If you are using timer 1 in mode 0, these 8 bits of count we are going to be loading TH1 and 5 bits we are going to be loading TL1. The next mode of operation is by configuring M1, M0 as 01, which is mode 1, a 16-bit timer. In this 16-bit timer, both THX as well as TLX will combine for placing the 16-bit count into the registers. For timer 1, we use TH1 and TL1. For timer 0, we will use TH0 and TL0. The next mode of operation by configuring M1, M0 bits as 10, which is mode 2, we'll call as 8-bit auto reload mode. In this 8-bit auto reload mode, only the TLX registers are used for timing or counting purpose, whereas THX will contain the load initially initiated or initialized to TLX registers. So once the count in TLX register is overflown, that is from FF to 00, then the contents of THX will be loaded into TLX. So when we configure in mode 2, the timers will be used in 8-bit mode. Next, if we configure the M1, M0 bits as 11, then the mode of operation is mode 3, which is split timer mode. In this split timer mode, the 16-bit timer is divided into two 8-bit timers, that is THX and TLX, which will act as a separate 8-bit timers. The next one is a TCON register. For configuring and controlling the timers, we have to program the TCON register. TCON is an 8-bit control register and contain a timer and interrupt flags. The various bits here we are having is TF1. This TF1, it is for timer 1 overflow. Whatever the count which we are loaded into the registers of timer 1, whenever they are overflow from the maximum value to 00, then the overflow will be generated on TF1. So this TF1 bit is equivalent to 0. It indicates the timer 1 overflow occurred. That is, timer 1 goes to its maximum and roll over back to 0. If TF1 is equivalent to 0, that indicates the timer 1 overflow is not occurred. So still some more count will be takes place. And it is cleared through programming. In the timer 1 overflow interrupt service routine, this bit will get cleared automatically while exiting from the ISR. The next bit is TR1. This timer run control bit is used to program the timer either to start the timing or counting application. If you configure the bit is equivalent to 0, we can stop the timer or counting purpose. If the TR1 bit is equivalent to 1, then the timer 1 will start functioning. If TR1 bit is reset, that is assigned with a 0, then the timer 1 will stop functioning. It is set and cleared by programming. The next bit is bit 5, which is TF0, timer 0 overflow flag. Whatever the count which you are loaded into the timer 0 registers, whenever it overflows from the maximum value to 00, then this overflow will occur. If TF0 is equivalent to 1, it indicates the timer 0 overflow is occurred. That indicates the timer 0 goes to its maximum and roll back to 0. If TF0 is equivalent to 0, it indicates the timer 0 overflow is not occurred. This bit TF0 can be cleared by programming it. In the timer 0 overflow interrupt service routine ISR, this bit will get cleared automatically while coming out of the ISR. The next bit is bit 4, which is TR0. This bit is to configure to start or stop the timer 0. So TR0, which is timer 0 run control bit. If TR0 is equivalent to 1, timer 0 start functioning. If TR bit is equivalent to 0, then the timer 0 stops functioning. It is set and cleared by programming. The next bit is bit 3, which is IE1, which is external interrupt 1 edge flag. If this IE1 is equivalent to 1, then it indicates an interrupt is occurred on INT1. For 8051, we have two interrupt pins, that is INT1 and INT0. If IE1 is equivalent to 0, it indicates external interrupt 1 is processed. This is set and cleared by hardware. The next bit is bit 2. This bit 2 is IT1, which is an external interrupt 1 trigger type select bit. If IT1 is equivalent to 1, it indicates an interrupt occur on falling edge of the INT1 pin. If IT1 is equivalent to 0, it indicates an interrupt occurs on low level at INT1 instruction. The next bit is bit 1, which is IE0, which is external interrupt 0 edge flag. When IE0 is equivalent to 1, it indicates an external interrupt 0 is occurred on the line INT0 bar. If IE0 is equivalent to 0, it indicates the external interrupt 0 which is occurred on INT0 bar is processed. This bit can set or cleared by the hardware. The next bit is bit 0, which is IT0, external interrupt 0, a trigger type select bit. This bit is used for finding out the interrupt occurrence at where falling edge or low level. If IT0 is equivalent to 1, it indicates an interrupt occur on falling edge on the line INT0 pin. If IT0 is equivalent to 0, it indicates the interrupt occur the low level at INT0 pin. Now we will see the various modes of operation of the timers. Timers have their operation modes which are selected the bits in T mode register using M0 and M1 bit combination. M1 M0 is 00, then it is timer 0, 01 mode 1, 10 mode 2, 11 mode 3. The timers can configure in the following modes. Mode 0, which is 13-bit timer. If you configure the timers in mode 1, it is 16-bit timers. If you configure the timers in mode 2, it is 8-bit auto reload timer mode. The next mode is mode 3. If you configure the timers in mode 3, it will act as split timers. Now we will see the in detail description of each and every mode of operation. What is the count and what is the maximum count we can have in each and every mode, we will see in detail. Before going to the timer modes, the clock pulses which are required for the timers will be provided by this timer counter logic. The oscillator frequency will be divided by 12 for matching the mission cycle, and this will be sent if you configure the timer as timing purpose, and if you are configuring this one as counters, then the T1 or T0 input will be passed the signals. This switch, either it will be connected to timers or it will be connected to counter depending upon C by T bar. If C by T bar is equivalent to 0, then this switch will be connected for this timer outputs, timer operations. If C by T bar is equivalent to 1, this switch will be connected for counting applications. So whatever the pulses which we are getting for the timers or counters will be passed to the timer stages based upon these bits which are there in the register. The first one is a gate bit in T mode register. The second one is For this AND gate, we are going to give one input is timer 1, timer run 1 or 0. If it is for timer 1, TR1. If it is for timer 0, it is TR0, whatever we are configured in TCON register. If the timer 0 or timer 1 run bit is equivalent to 0. If run bit is equivalent to 0, irrespective of the second input of AND gate, this will pass the AND gate output to logic 0. It indicates this switch will be open circuited because the timer is not activated. So for activating the timers, we have to configure the TR bit as 1. When we configure the TR bit is 1, the output of the AND gate will be depends upon the output of this OR gate. This OR gate, if it provides 1, if this OR gate will provides 1, then 1 AND with 1, which is a 1, so this will closes the switch. Suppose if the inputs of OR gate causes a 0, then the output of AND gate will become 0, then the switch will be open circuited. The required events or clock pulses will not reach to the timing stages. Now, what are the various inputs we are going to give for the OR gate is, one input is gate bit in T mode register. So this gate bit, it is used for enabling the timers and counters. Only INT0 and INT1 is high and TR1 is set. Already we have discussed with respect to TR1. Next, what about INT0 and INT1? So when we are written the gate bit is equivalent to 1 and the output of this one is equivalent to 0, then this bit is going to be depends upon INT1 or INT0. So if there is a interrupt on INT1 or INT0, which is an external interrupt, then the output of this OR gate is equivalent to 1, which will provide the output of this one is going to be 1, which will make the switch closed. If gate bit, if you are configured as 0, output of OR gate, NOT gate is 1, this will directly makes 1, no need of depending upon the external interrupts pin INT0 and INT1. So this is the circuitry we use for the control logic to pass the events of the counters to the counters or the clock pulses required for timer stages. Next, mode 0, which is a 13-bit timer. Mode 0 is a 13-bit timer mode for which 8 bits of THX and 5 bits of TLX are used. The TLX bits we use as prescaler. As we know, the TX registers, either it may be T1 or T0 register, which is a 16-bit size, that is D0 to D7. For 13-bit application, the TH0 or TH1 will be loaded with 8 bits, that is D0 to D7, whereas TLX, which is TL0 or TL1, will be loaded with only 5 bits. The upper 3 bits are not configured. That means they will be written as 0. So as shown in figure, 8-bit of THX and lower 5 bits of TLX are used to form a total 13-bit timer. The higher 3 bits of TLX should be written as 0 while using as timer mode 0, or it will affect the result. Now we will see what is the range of these counters. The size of the register or counter is a 13-bit size. So the total counts we can have is 2 to the power of 13, which will give us 8192. If we are configuring as counters, the maximum count it can take place is 8192. If you are using time pulses, then the maximum pulses it is going to generate is 8192. The range always counting will starts from 0, 1, 2, 3 like this. So the maximum count we can have is 8192 minus 1, which is 8191. So the count will be takes place from 0 to 8191. This is the range for mode 0. Whatever the pulses which we have seen in the earlier figure, those pulses will be given. For every input of this pulse, the TLX will be incremented by 1. For every pulse input, the TLX will start incrementing by 1. Whenever it reaches FF, from the initialized value to FF, again if any pulse input is generated, FF plus 1, it will be rolled back to 0, 0. Whenever it is rolled back to 0, 0, it is going to be increment the THX by 1. So the TLX again it will start counting. So for every roll over from FF to 0, 0, the THX will be incremented by 1. Once the THX register is rolled back from FF to 0, 0, then it will generate a overflow on TFX. If it is timer 0, TF0. If it is timer 1, it is TF1. So which is used for generating a interrupt indicating the given task is done. So as TLX is a 5-bit, the pulse input is divided by 32 in TL register, so that the TH count the original frequency by a total of 384 decimal. Next, mode 1. When we configure the timers in mode 1, it will act as 16-bit timers. Mode 1 is a 16-bit timer mode for which 8 bits of THX and 8 bits of TLX are used to form a total 16-bit register. In the count, the lower 4 bits are loaded into TLX, the upper 8 bits are loaded into THX out of 16-bit TX register. So here also the timer 1, if it is timer 1, T0 register, for timer 1, T1 register, which is having two 8-bit registers. As it is 16-bit timer, the functionality is same as that of mode 0. Only the difference is how many bits we are using for timing or counting purpose. As 16 bits are used, the range of numbers we can have is 2 to the power of 16, which will give us 65,536 maximum counts. The count will start from 1, 2, 0, 1, 2, 3 like this. The maximum value we can have is 65536 minus 1 because 0 is included, which is resulting the maximum count we can have is 65535. So the range is starts from 0 and it will ends with the maximum value as 65535 whenever you use the timers in mode 1. Then for mode 1 operation, whenever any pulse input is given, the TLX, which is 8-bit register, is incremented by 1. So this increment will be takes place once the TLX register incremented up to FF. Whenever again any pulse input is generated, this will be rolled back from FF to 0, 0. Whenever this is rolled back, then the THX register will be incremented by 1. For every rollback of TLX register, the THX register will be incremented and it will reach as maximum count is FF. Once it will roll back from FF to 0, 0, it will generate the overflow on TFX. When TFX is activated, it will generate an interrupt. The next one is mode 2, which is 8-bit auto reload timer mode. In this mode, load the THX 8-bit value only. The counting will be takes place with only TLX. When the timer gets started, the THX value gets automatically loaded to TLX register and TLX starts counting from that particular value. Whenever a rollover is occurred, that is from FF to 00, then the TFX flag get set and again the THX value which we are initialized that will be reloaded into the TLX register. That's why it is called auto reload mode. For every clock pulse, the TLX will be incremented by 1. The maximum count it will reach us to FF. Whenever the count changes from FF to 00, that is rollback is occurred, it will generate a overflow on TF0 or TF1. Then the same control signal again it is used for reloading the value of THX into TLX. So this it is usually mainly for baud rate generation. The next mode of operation is mode 3, which is a split timer mode. Timer 0 and timer 1 may be programmed to be in mode 0, mode 1, mode 2 independently of similar mode of the other timers. This is not true for mode 3. The timers do not operate independently if mode 3 is chosen for timer 0. Placing the timer 1 in mode 3 causes it to stop counting. The control bit TR1 and the timer flag 1, that is TF1, are then used by timer 0. As timer 0 is in mode 0, becomes two separate 8-bit timers. The TL0 is controlled by the arrangement of figure shown and the timer flag will overflow on TF0. So whenever the pulse is raised, then it will increment the THX register. Whenever it is rolled back from FF to 00, then it will increment the TFH, that is TFX flag, which will generate an interrupt. The other 8-bit register which we can use with the oscillator frequency divided by 12 with the control of TR1. Even though it is for timer 0, the TR1 bit is used for controlling this timer. So this will act as one 8-bit timer and this will act as the other 8-bit timer. The first 8-bit timer will be controlled by TR0. Even though it is timer 0, the TR1 bit is used for controlling the timer 0 in the split timer mode. So whenever this pulses is occurred, then the THX will be incremented. Whenever the maximum count is reaches, for the next pulse it will be rolled back to 00. Whenever the count is rolled back maximum value to 00, then it will generate a overflow on TF0, which will cause us to generate an interrupt. So now for this case, the TF0 it is used for the first 8-bit timer, whereas for the second 8-bit timer, even though it is timer 0, it will be generated on TF1 if we configure mode 3 for timer 0. The timer 0 in mode 3 becomes two separate 8-bit timers. TL0 is controlled by the arrangement shown in figure and the timer flag TF0 when overflows. This is TLX. Next, the THX receive the timer clock under the control of TR1, even though it is timer 0, and set the overflow on TF1 flag when occurs. Still, the timer 0 it is operating in mode 3, but timer 1 can be operated in mode 0, mode 1, mode 2. No interrupt is generated because TF1 and TF0 are utilized by these split timers. So the timer 1 as timer 0 using TF1 for overflow. The other application for the timers is we can program these timers as counters. The timers and counters differ by the source of clock pulses to the counter. If the C by T bar is equivalent to 1 in the T mode register, which will enable the pulses from TX pin to reach the control circuit. When used as timer, a clock pulse are sourced from the oscillator through the divided by 12 circuit. When used as counter, the pin T0 P port 3.4 supply the pulses to counter 0, and port 3.5, which is pin T1, it supplies the pulses to counter 1. When C by T bar is equivalent to 1 in T mode register to enable the pulses from THX pin to reach the control circuit. A change on input from high to low between the samples pulses will increment the counter. It has to maintain low for 1 mission cycle at least. For programming the timers or counter, the various steps we have to follow is load the T mode register value for timer 0 or timer 1 in any one of the mode. Then the calculated THX value we have to load into THX register, and the calculated TLX value will be loaded into the TLX register. Then we have to start the timer by programming the TRX bit for timer 0 TR0, for timer 1 TR1. Pull TFX flag. Every time we have to check the status of TF0 or TF1. Whenever it's set, then the timing application is done. Otherwise, we have to wait in looping. Pull TFX flag till it does not get set. Stop the timer by clearing the TRX bit after the overflow is occurred. Clear the timer flag in TFX bit. Repeat the first step to 7th step again for the delay. With this, I'll conclude the timers and counters of 8051. The various SFRs we are having for timers are T0, T1, T mode register and T-con register. The timers we can use as timers or counter by programming the T-con and T mode register. The count values or timer values will be loaded into the T0 or T1 register correspondingly for timer 0 and timer 1. For every event occur, the count in the registers will be incremented. Whenever it overflows from the maximum value to 00, then it will generate a timer overflow, which will cause us to generate an interrupt. Thank you all. If you have any doubts or any information to be clarified, you can put on the comment section. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.